Hello my dear students, welcome back to NEET World. So in this session we will be continuing our discussion on aldehydes, ketones, carboxylic acids. Okay. So in the last sessions we have discussed the EAPCET nomenclature of the aldehydes, ketones, carboxylic acid and also its preparation methods, then chemical properties. Okay. So the important chemical properties are also discussed. Yeah. So in this session we will be discussing some named reactions. See, in the last class I have discussed Rosenman reduction. Okay, these are some important named reactions we must know. Okay, the first one here is Rosenman reduction is done. Okay, Stephen reduction is Stephen reduction or Stephen reaction. Okay, it's not reduction, it's a reaction. Okay, so alkyl nitriles. Stephen reduction or Stephen reaction. Alkyl nitriles converts into aldehydes. Yes, this is also discussed. Okay, so what happens in nitriles? I mean Stephen reduction. So here alkyl nitriles like C triple bond N will be there. Okay, so this triple bond N is there now, that is converting into R C double bond O H. Okay, so what is happening here? In the place of nitrogen we are making one oxygen and one hydrogen. Okay, so it is called a Stephen reduction or Stephen reaction. Now what is the reagent used here? SnCl2 plus HCl. Okay, this is the reagent used. Okay, next Etor's oxidation or Etor's reaction. So now what happens? Alkyl benzenes will be converting into benzaldehyde. Okay, it means toluene, if you take the example toluene you can take, so CH3 you can take and treat this with chromyl chloride, CrO2Cl2. What is a chromyl chloride means? CrO2Cl2. Okay, so CrO2Cl2. So this is a chromyl chloride that gives you benzaldehyde. Okay, aldehyde conversion. So alkyl group is converted or oxidized to aldehyde, alkyl group to aldehydic form. Toluene, benzaldehyde. So what's the reagent used? Chromyl chloride, CrO2Cl2. Okay, right. The next reaction here, Gutterman-Koch reaction. So what happens in Gutterman-Koch reaction? A benzene ring react with carbonyl group CO plus HCl in presence of AlCl3 reagent, anhydrous AlCl3 form. So now what happens? This COHCl, so this will form HCOCl. Okay, so this chlorine is removed along with this AlCl3 as a AlCl4 minus. So now this whatever the aldehyde group is there now, that will be inserted over this benzene, so that you will get a benzaldehydic product like COH. This is your final product. Okay, is this clear? Right. The next Gutterman-Koch is also discussed in the last class. Next, what about Riemer-Tiemann reaction? Yeah, we discussed this in alcohols phenols chapter. So what happens? A phenol upon treating with chloro forms CHCl3 in basic medium like NaOH gives us salicylaldehyde. Okay, so ortho product will be major here. This is the final major product. Okay, right. So this is also done. Yeah, we need to discuss aldol reaction now. Cannizzaro reaction we will discuss. The next Clemmensen reduction is also done. So what happens? Aldehydes, ketones converts into alkanes. Okay, yeah, we discussed this in the last class. Same thing happens in Wolff-Kishner reduction, but the specific reagents here we are using in Clemmensen and Wolff-Kishner is important. So in Clemmensen we are using zinc amalgam in acidic medium like HCl. Okay, whereas in Wolff-Kishner reduction we are using hydrazine in basic medium like KOH under heating condition gives you hydrocarbon. Okay, the next Popoff's rule. What is this Popoff's rule? Whenever we have ketones, these ketones are resistant towards oxidation, but if we use a strong oxidizing agents like KMnO4 in basic medium or concentrated nitric acid HNO3, the oxidation of ketones takes place. So ketones upon oxidation using concentrated HNO3 gives you carboxylic acids. Okay, so when an unsymmetrical ketone is taken, the carbonyl group of that unsymmetrical ketone will goes with a smaller alkyl chain. Okay, so we will get two carboxylic acid products. The carbonyl group of ketone goes with a smaller alkyl group containing chain. Okay, hope the discussion is clear. Now let us discuss aldol followed by Cannizzaro. The next other chemical reaction, other named reactions will also be covered in the sessions. Okay, right. So just if you are new to this channel, click on the follow button and stay connected with us. Okay, right. Let's continue our discussion, and before going to that, whatever we discussed, if this discussion is clear till now, just click on the like button and you can share with your friends if they are preparing for JEE, NEET or EAPCET exams. Okay, right. Let's move forward with aldol condensation. Yeah, so reactions involving alpha hydrogen. So till now whatever we have studied, those are of different type of reaction, but here in these reactions alpha hydrogen of carbonyl groups is participating. So now what happens here? See, just take an aldehyde or a ketone. Okay, you can take aldehyde or ketone, but it should contain one alpha hydrogen. What do we mean by alpha hydrogen? See what I am saying, carbonyl compounds, it can be aldehyde or it can be ketone, but it should contain alpha hydrogen. What do we mean by alpha hydrogens here? See, the carbonyl group is there now. To this carbonyl group carbon, adjacent carbon is called alpha carbon, hydrogens are alpha hydrogens. So these alpha hydrogens should present in order to show this aldol condensation. Okay, so now alpha hydrogen containing carbonyl compounds like aldehydes or ketones with dilute base, with what? With dilute base like NaOH or CaOH twice, like that, NaOH or CaOH twice you can take. So dilute base you consider, dilute base, okay, dilute base gives beta hydroxy carbonyl compound. What it will gives? Beta hydroxy carbonyl compound. This is called aldol. What we can call? It's called aldol. Okay, right. So upon this aldol formed, beta hydroxy carbonyl compound is formed now. Upon further heating, dehydration takes place and gives alpha beta unsaturated product. This is a condensation product. Okay, alpha beta unsaturated product, unsaturated carbonyl compound is formed. Okay, so this is what the final product. Now how can you write the reaction here? So whenever we have two carbonyl compounds, it means 2 moles of carbonyl compounds having alpha hydrogens. What they should have? Alpha hydrogens. We need to treat this with dilute base. Okay, I will tell you one tricky way to answer this. Okay, we will get a aldol product first. Aldol product upon heating gives alpha beta unsaturated compound. Okay, I will tell you, just follow me along with. C double bond O H CH3 here plus C double bond O CH3H. Okay, now what happens is these alpha hydrogens are there now, these are acidic. Whenever we are treating with base, this base abstracts the acidic protons. Okay, so now if I use one base, it means if I use NaOH base here, what happens? It's abstract one proton first. Okay, this acidic proton it will take, okay, OH minus will take this acidic proton, so it will forms HCO CH2 minus. So this minus will attack on this carbonyl group. Why? Because it's electron rich now, and this is carbon is electron deficient, right? So now what happens? We are going to make a bond between CH2 and this carbon, O minus CH3, like this. See, followed by hydrolysis, followed by water, adding water, it will convert this O minus to OH. Okay, so see here alpha beta with respect to carbonyl group. So beta hydroxy carbonyl compound, this is called aldol. Okay, so this aldol upon heating what happens? Again we have acidic protons now, so one more acidic proton and this OH removed as water. Okay, and we will get a HCO CH double bond CH CH3 product. So see here alpha beta unsaturated product is formed. Okay, is this clear guys? Is this clear whatever we discussed? Whatever we discussed, is that clear or not? Yeah, if it is clear, please mention clear in the chat box. Yeah, let's move forward. Yeah, I will tell you one tricky way to solve this question now. So just take 3 alpha hydrogens are there now, 2 I am writing here and 1 more here. Place C double bond O. Okay, so now what I am saying is you just remove these hydrogens, 2 hydrogens and this oxygen as a water. The final product formed is this one. See, HCO. Here we have CH, right? CH. Now 2 hydrogens and oxygen is removed now. So attach with this carbon with 2 bonds. Okay, and the next here 1 hydrogen and 1 CH3. See, both products are same. Okay, so this is the simple way you can make your final product. Okay, in the yesterday's class I have added one more reaction for aldol condensation, that is cross aldol reaction. What is that? Cross aldol. So cross aldol, here I already mentioned. Yeah, cross aldol. What happens? Two different aldehydes are two different compounds. Like see, this is one aldehyde, like one carbonyl compound, and second one more I am taking. Let us say it has some R dash type of group. Okay, now what happens? This is one, this is second one, two different aldehydes now. So I can have a product by the combination of these molecules with itself, that is we are going to get 1,1 type, like AA type product here, and if it combines with itself we will get BB type product here. Okay, because let us say this is A, this is B. Now AA can combine and give an aldol product, normal aldol. Okay, and BB can combine with itself and give a aldol product. Now cross aldol means oxygen from this molecule, hydrogen, alpha hydrogen from this molecule. Okay, we will get one product now, something like AB type molecule. Okay, this is called cross aldol now. Now oxygen from this carbonyl group, hydrogen from here gives you BA type product now. Yeah, so finally how many products you got? How many types of products we got? 1, 2, 3, 4. So 4 products will be formed by this aldol condensation reactions. Whether if the 2 carbonyl compounds are different, you should call it as cross aldol. If they are same, normal aldol condensation, like this. Okay, right. Let us move forward. Yeah, intramolecular aldol condensation. What do we mean by intramolecular aldol condensation? See what I am making here. Otherwise, let us take one. One cyclohexene I am taking, and I am treating this with ozone in presence of zinc as a reducing agent, followed by water, addition of water. So now what happens here is ozonolysis takes place and gives you a molecule A. This upon treating with dilute NaOH followed by heating gives you B. Now they will ask us what is AB in this reaction. These model questions are frequently asked in the exam. So it's very important to know this. See what happens, ozonolysis of alkenes, what they will produce? It will produce as carbonyl compounds. How do you do? The tricky way is to cut this double bond and insert oxygen above and below of this alkene carbons, right? So that you will get, see here O, here also O, like this we got. So this is our A, 1, 2, 3, 4, 5, 6. So 6 carbons, at first carbon and last carbon we have carbonyl groups, right? So 1, 2, 3, 4, 5, 6, like this we have. So this is our A. So now A is treated with what? Dilute NaOH under heating condition. So what happens, tell me? So at this alpha carbon we have alpha hydrogens, or at this one also we have alpha hydrogens. So now any of these alpha hydrogens will be removed with this base, because we know dilute base, carbonyl compound with dilute base. What happens? Aldol condensation takes place now. So you can remove these hydrogens and this group. So 1, 2, 3, 4, 5. So we are going to get a 5-membered ring now. Okay, see, because if I use this alpha hydrogens and this oxygen as a water, I am eliminating. Okay, so it gives you an aldol product. See, 1, 2, 3, 4, 5. So 5-membered ring you are going to form. Okay, so let us say 1, 2, 3, 4, 5. So on 5th carbon we have an aldehyde group. Yes, right, like this. And between 1st carbon and 5th carbon we are making a double bond. So you can make a double bond. See, alpha beta unsaturated carbonyl compound is formed right now. So it means within the molecule aldol condensation is taking place now. So this is called intramolecular aldol condensation. What is that? Within the molecule, from here we are getting alpha hydrogens, from here we are getting an oxygen. So within the molecule aldol condensation taking. In the previous slides if you see this, we are taking two different molecules, two separate molecules, right? Now two separate molecules we are taking in aldol, but here within the molecule we have two carbonyl sites with alpha hydrogens that are involving and giving a final product like this. So if both carbonyl compounds present in the same molecule, we can say it as a intramolecular aldol condensation. Hope the discussion is clear and final product formed is also clear, right? So these are some important model questions, I mean model examples to be focused, whether if you are preparing for NEET or JEE exams, particularly JEE. Okay, right. Here when it comes to Cannizzaro reaction, what is this Cannizzaro reaction? Yeah, Cannizzaro reactions means here carbonyl compounds without any alpha hydrogens, should be treated with upon treating with concentrated base. With what? Concentrated base. Concentrated NaOH, KOH like that. Concentrated base gives an gives a carboxylic acid, that is an oxidized product, and an alcohol, a reduced product is formed. Okay, so it means it's very easy, just follow. What is the primary condition here I am mentioning? Carbonyl compound should not contain any alpha hydrogen. So do we have any alpha hydrogen here? No. See, to this carbonyl carbon, if there is adjacent carbon and on adjacent carbon any hydrogens are present, those are alpha hydrogens. But there is no adjacent carbon here right now. It means there is no alpha carbon and alpha hydrogens are not present. So this kind of system which does not have alpha hydrogens treated with concentrated base, concentrated NaOH. What happens is this base will directly attack on this electrophilic center because there is no acidic sensitive group like acidic hydrogens or nothing like that. So this group NaOH now here act as a nucleophile instead of base, it will act as a nucleophile. So now actually in the reaction you should take 2 moles of this molecule, 2 moles of this formaldehydes gives you 1 mole of oxidized product, that is carboxylate ion, okay, and 1 mole is reduced. See, formic acid, formaldehyde giving you formic acid, a carboxylic acid respect to carboxylic acid is formed, okay, and a reduced product, just add 1 hydrogen to this, it becomes methanol, no? CH3OH it becomes, and a alcohol, a reduced product is formed. This is how the reaction, this is what the products formed during the reaction. Now look at the mechanism. What happens is, out of these 2 moles, I am taking 1 mole only first of all, this 1 mole and this concentrated NaOH. So concentrated base, or you can take like that, okay. So now here concentrated OH minus will be attacking here, carbonyl groups goes up, O minus, H, and this OH here. And after this, see what happens after this, what happens is on same carbon we have O minus and OH. Okay, this is relatively less stable due to the repulsive interactions between the lone pair electrons of these oxygens. Okay, so now what happens, again it comes back like this, O minus comes back, one of the groups should eliminate from here. Okay, since we are doing the reaction in basic medium, I mean concentrated NaOH medium, there will be lot of OH minus ions, so it will not allow this OH minus ion to come out. Okay, so OH minus ion will not come out now. What is the other alternate? Here hydride ion is the only possible thing to come out, right? So we are going to get H, C double bond O, OH, and hydride ion it is releasing here now. So this hydride ion, how many moles we are initially taken? Here it should be 2 moles, but I used only till now I used 1. So the another mole of formaldehyde is there now. So on that another molecule of this formaldehyde, this hydride ion will attack now. So if it is attacking, what happens, tell me? What happens, tell me? H, C, H, this new hydride ion is attacking, so that it will goes up. So hydride ion, it becomes O minus. So we got CH3O minus. This is methoxide ion we got, right? We are almost done with the question. Okay, so this methoxide ion will abstract this acidic proton and gives us methanol. Okay, this methoxide ion, whatever it is formed, abstract this acidic proton and forms methanol, plus this will be a formate ion now, formate O minus, formate, and that sodium ion, sodium formate, that's it. Like this, we will get a carboxylate ion and we will get an alcohol. Okay, so this is how you need to write the mechanism. Guys, if the mechanism that I have discussed till now, if it is clear, please click on the like button. What is happening here? There are 2 steps to be remembered. First step is attacking of OH group directly on the carbonyl group carbon, okay, and forming an oxidized carboxylate ion, carboxylic acid. The second step, the hydride ion which is coming out as a living group in this step, in the first step, will be attacking on the one more carbonyl group. This is the nucleophile. So what are the nucleophiles involved in Cannizzaro reaction? One is OH minus ion and other one is hydride ion. Okay, so now hydride ion is coming from one molecule, will be attacking on the other molecule. Okay, so that will get a addition of hydrogen, reduction now. So reduction product here, addition of oxygen, it's an oxidation now, oxidation product. Like that we got 2 products. Okay, I hope the concept is clear, right? Guys, if the discussion and the concept is clear, please click on the like button and let's move forward with a few more examples. See, in the same reaction, in the same Cannizzaro reaction, I will tell you about cross Cannizzaro. Cross Cannizzaro means, just see what I am taking here. I am taking formaldehyde here, okay, and along with that I am taking benzaldehyde. Cross means like A and B, like 2 different we are taking, na, that's it. Okay, in the previous case, only formaldehydes I have taken, 2 molecules or 2 moles of formaldehydes, but here one is formaldehyde, another one is benzaldehyde. If you observe, both of them are not having alpha hydrogen. So here also no alpha hydrogen. Okay, there should not be any alpha hydrogen. Yes, now I am treating this with concentrated NaOH. Now what happens, concentrated NaOH, you mention it as concentrated NaOH in the definition instead of concentrated base. Okay, or now what happens, tell me, again this OH minus ion, there is no acidic proton to abstract, there is no alpha proton to abstract, so OH minus directly attack on these carbonyl groups, but out of these 2 it will attack only on one of the carbonyl group. So on which it will attack, that is a main important question or the concept to be understood. So how do you get this? Yeah, it's simple. See, OH minus, this OH minus will attack on that carbonyl group which is more electron deficient or more electrophilic nature. See, here both sides we have only hydrogens, right? But here we have a benzene like phenyl ring. This pi electrons of phenyl ring is in conjugation with this carbonyl group. So it is not electron deficient as we compare with this. So which is more electron deficient? Formaldehyde. So the electron deficient species, electron deficient one, more electron deficient one, more electron deficient carbonyl compound will be will be oxidized. Which is oxidized? More electron deficient carbonyl compound will get oxidized by addition of this OH minus. So if we add OH minus, what is the product formed here? It becomes O minus H and OH like this. So now next what happens? That hydride elimination. So given back, hydride comes out, HCO OH. See, formaldehyde converted into formic acid. Okay, hydride ion, whatever it is released here, will attack on this benzaldehyde and gives you a benzyl alcohol, CH2OH. Okay, so this is a sodium formate. Okay, so identifying these products are very important step in cross Cannizzaro reaction. Okay, this is also frequently asked question mark. Okay, right. So how we are deciding? Look at the electron deficiency. The one which is more electron deficient get oxidized to carboxylate ion. The more electron density containing species or less electron deficient species getting reduced to its respective alcohol. Okay, hope the concept is clear. Now next one, similar to aldol, we discussed aldol, cross aldol, internal aldol. Cannizzaro also, Cannizzaro, cross Cannizzaro, internal Cannizzaro. So here we have intramolecular Cannizzaro reaction. So it means within the molecule, one aldehyde group will undergo oxidation, other will undergo reduction. Okay, so let us say I am adding two carbonyl groups over here. Okay, and for this, let me change the position of carbonyl group. Yeah, so here I am writing carbonyl group. So two carbonyl groups, none of them have alpha hydrogens. Okay, now what I am doing is, here I am inserting one nitro group. What I am inserting? One nitro group. So we know nitro group is electron withdrawing group. What type of group? Electron withdrawing group. Stronger electron withdrawing group, and treat this with a concentrated NaOH. Now tell me what happens. Now just now in intramolecular or cross Cannizzaro we have discussed this like OH minus hydroxide ion, OH minus will attack on more electron deficient site. Right now, out of these two carbonyls, which is more electron deficient? Tell me. See, look at this electron withdrawing group. It will withdraw the electrons from the ortho positions and this para position. Therefore, this para position carbonyl group is more electron deficient now. So OH minus attack on this para position carbonyl group. It means this will get oxidized, hydride ion shifts here, this will get reduced. Okay. So the product formed here is this is the final product. Okay, so this is oxidized, this is reduced. Okay, one of the very important reaction for JEE particularly and also for NEET. Okay, now what is happening here? What is happening here? What is happening here? The electron deficient carbonyl group getting oxidized. Okay, electron deficient carbonyl group is getting oxidized, the other one is getting reduced. Okay, now based on this explanation, please provide the answer for this question. So I am expecting answer for this question in the chat box from those who are watching it. Please answer me what will be your answer for this question. I have electron releasing group, previously electron withdrawing group, now I have electron releasing groups, and what will be the product? Okay, what will be the product? It means here I am saying this aldehyde group is 1 and this aldehyde group has 2. So which of this aldehyde group will get oxidized and which reduces? Tell me your answer in the chat box. See, if 1 gets oxidized, 1 oxidized, 2 reduced, or 2 oxidized means 2 oxidized, 1 reduced. Mention in that way in the chat box. I will definitely look into it. If there is any confusion or missing clarity, I will provide you the proper explanation. Even if you give me your answer in the chat box, I will provide you the proper explanation there itself. Okay, so please try to give me. So do not worry about right or wrong, you just mention your answer in the chat box. Okay, whether you are watching it live, recorded version later, you please provide me your answer, I will be definitely consider it and I will tell you if there is any mistake. Okay, right. Right. Let's move forward. Yeah. Next. So what are the uses of aldehydes and ketones? Okay. So slowly we are moving towards carboxylic acids. Okay, just read these lines once. I will take some water. Yes, tell me what are the uses we have here. So aldehydes and ketones are used in chemical industries as solvents and starting materials. Means during a chemical reaction we will start with the substrate na? Yeah. So that substrates mostly it will be aldehydes they are saying. Okay. So aldehydes, ketones used as in chemical reactions as solvents, also as starting materials and reagents for synthesizing other products. Okay. So during the synthesis of other products it can be used as a solvents, or like acetone is a best polar aprotic solvent. Okay. It will be used in many synthetic applications. Okay, and it can be also used as starting materials in many chemical reactions. Okay, and formalin is an example. Formalin, that is nothing but formaldehyde. 40% aqueous formaldehyde solution is called formalin. So it will be used to preserve biological specimens. Okay, like if you see in our biology labs, like in botany or zoology labs, if you see, so what they will store that specimens na. So it contains what? Formalin is a solution, that liquid will be present to store them. Okay, next, formaldehyde also used as a disinfectant. Okay, then next, formaldehyde used in the manufacturing of synthetic polymers like bakelite. So bakelite is there now. So it is a polymer of phenol plus formaldehyde. What is it? It's a polymer of phenol plus formaldehyde. Okay, next, acetaldehyde used for silvering of mirror. So where it will be used? For silvering of mirrors it will be used. Okay. The next, benzaldehyde used as a flavoring agent in perfumery industry. Where it will be used? Benzaldehyde is used in as a flavoring agent in perfumery industry. Next, acetone. So acetone is a solvent used in industries and laboratory. Just now I mentioned there. So acetone is one of the best example for polar aprotic solvent used in many organic chemical reactions. Okay, it have good applications in industries and laboratory. Next, acetone is also used to remove, see, constituent of nail polish and removers. It is used to remove nail polish. Okay, next, aldehydes, many aldehydes and ketones like butyraldehyde, vanillin, acetophenone, okay, camphor, etc. are known for their odor and flavors. Okay, vanillin, one of the very good application that we are seeing, like vanillin ice cream, vanilla ice cream is there now. So it contains an aldehydic functional group. Okay, so these are having good odor and flavors also, and you much familiar with camphor also, no? So it also be having some kind of odor, right? Okay, next, carboxylic acid. What is the functional group we have for carboxylic acid? Like COOH, like this, right? So now there should be one R group, okay? So if this functional group is there, then you can say it is a carboxylic acid, okay? Right. Now how do you write the name of this this carboxylic acid? See, priority of the functional group is first while writing the IUPAC nomenclature, okay? Right. When we compare with the other functional group, priority is first given to carboxylic acid, so it is considered to be principal functional group in many IUPAC nomenclature of organic compounds, okay? Let me give you one example. Like this I have. So what is the name of this compound, they will ask, okay? This is one compound, this is second compound. Like this I am saying. See, functional group is here now, so start numbering from here, 1, 2, 3, 4. So 4 carbons means butane, okay? First position carboxylic acid, butane oic acid. So suffix, when you count the carboxylic acid group carbon also, the name of the compound should end with suffix. For the carboxylic acid is oic acid. What is this? Oic acid, okay? Right. Then next here, how can you write? See, 1, 2, 3, 4. So same 4 number of carbons, but second position we have hydroxy, OH group is there. So you just mention 2 hydroxy. See, both of them are functional groups, but priority should be given to carboxylic acid. It's a principal functional group now as per the IUPAC rules. So 1, 2, 3, 4. So whatever may be the other functional groups we have, do not bother about it. Based on the priority order, first fix one principal functional group. Remaining all other functional groups are considered to be as a prefixes only. Now while writing their names, follow alphabetical order, okay? So for example here I have hydroxy, and let us say here I have one amino group is there. So now just number it from principal functional group, then write the name by following alphabetical order for this, and end the name of this compound with oic acid, as our principal functional group is carboxylic acid. So it is mentioned as it is amino group, this is hydroxy. A comes first, compare with H as per alphabetical order. So 3 amino, 2 hydroxy, 3 amino, 2 hydroxy, butane oic acid, butane oic acid. This is the name of the compound, okay? Hope the concept and the discussion is clear, right? Let's move forward. Butane oic acid, okay? Right. See, one more compound I am giving you here, like this. There are 3 carboxylic acids. How do you name this? See, we cannot prioritize the chain from these terminals because all the carbons contain carboxylic acid. We should not ignore any of the carboxylic acid. So do not number the carboxylic acid, just mention numbering for this carbon chain like 1, 2, 3. So at first, second, third, we have 3 carboxylic acid now. So 1, 2, 3, like propane 1, 2, 3 tricarboxylic acid, or 1, 2, 3 propane tricarboxylic acid, okay, carboxylic acid. This is how you need to name, okay? See, I am using the word carboxylic acid when I am not counting the carboxylic acid carbon. If I count the carboxylic acid carbon like here, I should end the name with oic acid. Here I am not counting the carbon of these carboxylic acids, so it should be mentioned as carboxylic acid, tricarboxylic acid, okay? Is this clear? Clear now? Guys, if this is clear, just click on the like button. Right. The next nomenclature is done. Okay. So when it comes to common names, for example here, you are calling this as formic acid. Okay, why you are calling it as a formic acid? Because this comes from ants, from red ants. So in the Latin word like formica means ant. Since it is present in the ants, you should call it as a formic acid. So it is given based on its origin. Okay, it is originated from ants, red ants now. So that's why you are calling it as formic acid. See, we will feel sensation now when ant bites, we will feel little sensation, right? So that is because of this formic acid only. Okay, right. Next, acetic acid. Okay, so acetic acid, acetum is also a Latin word. Acetum means vinegar. So it is present in vinegar, that's why we are calling it as acetic acid. What is the IUPAC name of this acetic acid? It is 2 carbons now, ethanoic acid. Ethanoic acid. Butyric acid. See, butyric acid, because it is present in butter, so we are calling it as see, Latin butyrum means butter. Okay, since this is present in butter, you should call it as butyric acid. 1, 2, 3, 4 carbons are there. Butanoic acid, also called as a butyric acid, as a common name. Remember this. Okay, so these are some common names and IUPAC names. The discussion is completed. Now these are the compounds you must remember. I mean, their formulas to be noted, or it should be in your mind, because mostly while doing some chemical reaction, chemical synthetic reactions, they will provide the product formed here is a like succinic acid or crotonic acid, like that they will mention. So we cannot identify what is the starting material if we do not know the structure of that succinic acid or crotonic acid, whatever they are mentioning. Okay, so it's very good if you learn these names. See, formic acid means HCOOH, IUPAC name is methanoic acid. Okay, so acetic acid, ethanoic acid, just now we discussed. Propanoic acid means 3 carbons, right? Propanoic acid is the common name. Propanoic acid is a IUPAC name. So isobutyric acid, so 2-methyl propanoic acid here. Okay, then next here 1, 2, 3, 4, 5. See how many carbons are there? 1, 2, 3, 4, 5. So 5 carbons means pentanoic acid now. So pentane, 5 carbons now. V means 5. So valeric acid you can remember in the tricky way. So pentanoic acid, also called as a valeric acid, as a common name. Okay, caproic acid, that is nothing but hexane, 6 carbons. So capro, C, 6C. Okay, caproic acid, that is also called as N-caproic acid, which is hexanoic acid. Okay, then next, see what I am writing. If I write like this, it is called as glyoxal. What is that? It is called as glyoxal. But there is slight change here. One of this aldehyde is converted into carboxylic acid. So glyoxylic acid, this is called glyoxylic acid. Okay, or also called as oxoethanoic acid. See, 2 carbons are there now. So again keto group is there. So that is oxoethanoic acid. Okay, remember this. Aldehyde group is oxoethanoic acid. Next, here if you see, so lactic acid. What is lactic acid? Again important more. So one side OH and other side COOH. Okay, see, one side OH, other side COOH, and we have one hydrogen, one CH3. Like this you can remember. See, carbon, how many carbons? 1, 2, 3, one OH, one H and COOH. Okay, so this is called lactic acid. What is the IUPAC name? 1, 2, 3 are there now. So propane, second position hydrox, 2-hydroxy propanoic acid. Okay, that is called lactic acid. Okay, next, acrylic acid here. What is this? Acrylic acid. So acrylic acid means you just remember it as CH2 double bond CH COOH. This is called acrylic acid. Okay, you can write the IUPAC name propene, prop-2-enoic acid, prop-2-enoic acid. Okay, and the next, crotonic acid here it is caproic, it is crotonic. See, crotonic means same thing as acrylic acid, but instead of hydrogen we have one methyl group. So here COOH, crotonic acid, CH, double bond CH, here CH2 is there na, but here I am writing CH only, and in one more position we have methyl. Okay, so this is called a crotonic acid. Okay, so you just remember acrylic acid and crotonic acid are same. Okay, that's it. Next, benzoic acid means on phenyl ring, on benzene ring we have COOH, so benzoic acid. Okay, remember. Next, benzylic acid or phenyl lactic acid here. Okay, so this is different. Phenyl lactic acid means phenyl acetic acid. Okay, phenyl acetic acid or benzylic. See, this position is called benzylic position. So on this we have COOH. See, what makes the difference from here to here? There is one methylene group. So I can say benzoic acid and phenyl acetic acid. Okay, so this is benzyl acid, this is benzoic acid. So what makes the difference? These are homologous series we can say. So phenyl acetic acid and benzoic acid are homologous series. Okay, just they differ by CH2 unit. Then last one is cinnamic acid. What is the cinnamic acid? So COOH, CH, C6H5. So I will write the structure here just to see. CH, CH2. See, if this is the case, you should call it as a styrene. What is this? A styrene. But from this styrene, I am removing hydrogen and adding one COOH group. So now you can call it as cinnamic acid. Okay. So what is the name of this compound? Cinnamic acid. Okay, remember. Cinnamic acid. Okay, Novengel condensation is a reaction to be used to produce this. Okay. Next, Perkins reaction also used to get this product. Okay, cinnamic acid. Trans-cinnamic acid is a major product in that reaction. Next, succinic acid means, remember it in this way, CH, CH2, CH2, here COOH and here also COOH. So how many carbons we have? 1, 2, 3, 4. So 4 carbon succinic acid, it will be like this. Okay, once again succinic acid means like this. Next, cinnamic acid means, remember styrene. From styrene, remove hydrogen and replace with COOH. You can call it as cinnamic acid. Next, phenyl acetic acid. Phenyl acetic acid means phenyl group, CH2, COOH. Acetic acid is there now. Remove hydrogen, replace phenyl. Okay. Benzoic acid, benzene ring with COOH group. Okay. Crotonic acid means first understand acrylic acid. What is acrylic acid? CH2, CH, COOH. Again from CH2 replace with phenyl, replace with methyl, you will get crotonic acid. Okay. Like that, please remember these names, highly helpful in the exams. Directly we can expect a question from this. Directly or indirectly, but they will connect to the common names. Okay. So if they are making any question related to common names means mostly that will be belongs to carboxylic acids. Okay, because there are lot of names and they have lot of applications in the daily life. That's way. Okay, right. Right. So yeah, carboxylic acid also, again the carbon present in the carboxylic acid is also sp2 hybridized here. Okay, because 3 sigma bonds we have. So 3 sigma bonds means sp2 hybridization. Okay, so the 2 functional group, one is carbonyl group and one hydroxyl group are present in a carboxylic acid. Okay, so these 2 together joins to form a COOH carboxylic group. That's it. Then next, methods of preparation from primary alcohols by using oxidizing agents like KMnO4 or K2Cr2O7 or by Jones reagent, we can make conversion of primary alcohols to carboxylic acids. Okay, so these are the reagents, oxidizing agents can be used here. Okay, right. Next, okay, oxidation of aldehydes, ketones. Yesterday's class only we discussed. So we can oxidize aldehydes using oxidizing agents. For ketones particularly we required some specific reagents like HNO3, concentrated nitric acid, and KMnO4 under basic medium. Okay, like this we have to use. Next, hydrolysis of nitriles, those are nothing but cyanides. See, RC triple bond N. Okay, so what we are doing is we are adding water. So the oxygen will attack on this nitrogen carbon and it becomes imine first. So RC imine type of bond like this. Okay, it will be converts into amide. Okay, so partial hydrolysis of cyanides produces amides. What it will produces? Amides will be produced. So this is called amide. So amide again hydrolysis produces, complete hydrolysis here will get a carboxylic acid. So RCOOH is produced and ammonia gas is released. So now what you are seeing? Cyanides upon complete hydrolysis produces carboxylic acids. Okay, partial hydrolysis produces amides. See, even amides upon hydrolysis producing carboxylic acids. So both cyanides upon complete hydrolysis, carboxylic acids, amides upon hydrolysis, carboxylic acids. Okay, gas released here is ammonia. Okay, remember. Then next, from Grignard reagent. See, using Grignard reagent and carbon dioxide. See, RMGX I am using. So now what happens? This CO2 means you can write it in this way. So RMGX, R minus will attack here and this conjugation, I mean pi electrons to shifts towards oxygen side. So RCO, O minus it will forms. So this upon hydrolysis, because here it will be like a complex salt here. Okay, upon workup adding acidic hydrolysis gives you carboxylic acid. Okay, this is the final product form. Okay, so what is the thing? Ketones adding carboxyl Grignard reagent, carbon dioxide with Grignard reagent gives you carboxylic acid, remember. Next, hydrolysis of acid halides and acid anhydrides. So acid halides and acid anhydrides. So what happens if you add water? So just remove this halogen, place that OH group or COOH. Okay, hydrolysis of esters also produces carboxylic acid in the same manner. So what is esters here? R. Okay, so this alkoxide groups comes out when adding water and gives you carboxylic acid. Okay, right. So the next, preparation of aromatic acids from alkyl benzenes. Okay, so this will be discussed in the upcoming session. Okay, anyways, let me add few more points to this. Yeah, so just take this one last example because it will be finished. Okay, yeah. So alkyl benzenes, if you have on this benzylic position carbon, if at least one hydrogen is present, upon treating with KMnO4 gets completely oxidized to carboxylic acid. So benzoic acid is produced here. Okay, this is a reaction you can remember from aromatic alkyl benzenes to aromatic carboxylic acids. Okay, right. The next one is trihalogen. From trihalogen derivatives to trihalogen derivatives of hydrocarbons to carboxylic acids we need to discuss, right. So this will be continued in the next session. Okay, right. So the questions related to NEET, JEE, EAPCET from this chapter will be solved in the upcoming sessions. You just take the note of our discussion, and if any doubts are there, please mention in the chat box. Definitely I will give you clear-cut explanation for each and everything, okay, in a possible way. Okay, right. So stay connected with our NEET World channel. If you have any confusion, please feel free to mention. And thank you for watching. Stay connected with us. You can share with your friends. Thank you.